Hey everyone, welcome to Cassandra Lunch number 94, month and a half away from the big 100. If you guys have any topics that we can do for the big 100, feel free to drop it in the chat. Maybe we can do something special. If you're watching this on YouTube, you can drop it in the live chat or as a comment as well. Today's topic is going to be on StreamSets and Cassandra. I will be the speaker today. Co-organizers for this event are Rahul and myself. We are looking for guest speakers here at Cassandra Lunch, as well as Data Engineers Lunch, our sister lunch that occurs on Mondays. We're also looking for sponsors. If you're looking to sponsor Cassandra Lunch or Data Engineers Lunch, feel free to reach out to me. My email is listed below. We're a part of Data Community DC. Data Community DC believes in building an inclusive culture. So no matter your race, gender, sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, falls under Data Wranglers DC. So if you're interested in all the various events put on by Data Community DC, you can find out more at datacommunitydc.org. So what do we cover here at Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra in the ecosystem, right? So today's topic, we're going to talk about StreamSets and Cassandra. So we're going to be mainly using open source Cassandra, but we could also potentially use enterprise version of or a variant or some kind of tool like DataStax or Skilla or Amazon Key Spaces or Azure Cosmos DB, Yugabyte. There's a ton of variants out there. So anything that is Cassandra, talks Cassandra, or plays well with Cassandra, we cover here at Cassandra Lunch. If anyone's new to Cassandra Lunch, feel free to say hi, hello in the YouTube comments or Zoom chat. Say what you do with Cassandra or potentially what you hope to get out of Cassandra Lunch. Maybe there's a topic for you to learn and then teach the community here we have at Cassandra Lunch. Group rules, if you have a question, please ask it. Obviously, please be polite and courteous to others. But again, because this is a community, please do share what you know with us. If you have any questions or comments, maybe you've worked with StreamSets and Cassandra or any other topics that we've discussed in the past, present, or future, feel free to share what you know with us. Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is a way of life for us. DataStax is a partner and a sponsor. GW University helps provide in-venue space when we have in-person events. We also have some institutional and organizational sponsors. If anyone has a job offering or is looking for a job, feel free to drop any links you have in the YouTube comments or YouTube chat or Zoom chat, and we'll get them all transferred to and from. Or if they have any meetups or hackathons that they would like to promote, feel free to drop links to those as well. DataStax Astra currently has a build-a-thon ongoing right now. First month is wrapped up, so the second month is ongoing. So per month there's a challenge. So 3 months, 3 rounds of challenges. The top 3 winners for each round will qualify to present their ideas on demo day. So there's cash and swag prizes to be able to be won at the month level, as well as if you qualify for the demo day, there's also demo day cash and swag prices to be won. Anant is hiring, so if you're looking in becoming a full-time or part-time data platform operator, engineer, architect, feel free to reach out to us at careers.anant.us. Upcoming events, Cassandra Lunch happens every Thursday at noon Eastern, but we are looking at having a more variable time slot, as well as Data Engineers Lunch happens on Mondays at noon Eastern currently as well. All of these videos are available on our YouTube, youtube.com/anantcorp. So if you're watching on YouTube and you're not subscribed, be sure to subscribe. So in case you missed the live stream that we do directly to YouTube, you can always catch up to it after the fact. And all of these videos are under the Cassandra.Link or Cassandra Lunch playlist. We started recording around Cassandra Lunch 10, so we have about 80 videos available, all related to Cassandra and the ecosystem. Cassandra.Link should be your number one resource for all things Cassandra. This is a hand-curated resource by the team here at Anant. So anything that surrounds Cassandra, articles, videos, feeds, is aggregated on Cassandra.Link. So if you have any questions, be sure to check out Cassandra.Link to help answer those. And with that, we will go ahead and move on to our topic for today, StreamSets and Cassandra. Let me know if you guys can still see my screen.
Yes.
Okay, great. So in terms of questions or comments, feel free to speak up. I don't necessarily have a preference. If you feel more comfortable, you can drop something in the YouTube chat or the Zoom chat, and Max will be monitoring those and be transferring them over for me to see. So today's topic, we're going to cover StreamSets and Cassandra. So I have covered StreamSets previously for a data engineer's lunch, and that was strictly in the context of StreamSets for data engineering. So for today's topic, we're going to look at StreamSets in the context of how can we use it with Cassandra. And so we'll go over some introduction to StreamSets if you never used it, if you never heard about it, but essentially it's a data integration platform built for data ops. It's similar, if you see the screenshot here, it's similar to what the UI, similar to NiFi, right? We've covered NiFi and Cassandra, the building blocks, dragging, drawing arrows to build up data pipeline, essentially, right? It's different from Airflow, where you would write a Python DAG that builds out your DAG. In here, you're actually dragging and dropping, quote unquote, kind of a low code, no code data platform or data operations pipeline builder. But there are opportunities to build pipelines using code within the StreamSets UI as well, which is pretty interesting. But essentially, you can build streaming, batch, CDC, ETL, or machine learning Pythons directly from the UI and deploy it, your workloads to the cloud, or you can host it on Docker, which we'll be doing today for our demo. And essentially, the platform, there has a free tier. So I've been using the StreamSets UI for at least a month or two now. It's never asked me for a credit card. It hasn't charged me for anything. So it's definitely an easy way to get started and play with it. And with that, we get the data collector engine, which is the one we'll be using today. The transform engine, we'll talk about that in a second. We looked at the transform engine in our previous talk for data engineers lunch. So if you're interested in the transform engine, you can check it out on our YouTube channel, as well as control hub, which is the main UI that we'll be looking at for managing deployments, environments, connections, etc. And again, we'll be using self-managed deployments via Docker. And with the free tier of the DataOps platform, we get 2 active jobs, 2 active users, and 10 published pipelines. So you could potentially use StreamSets on your workloads without having to pay for it, depending on your use case and your usages. So the control hub, right? So control hub is the main top level component of the platform, right? So with the control hub, you build, run, monitor, and manage your pipelines at scale. Right now, we're just focusing on the usage with StreamSets and Cassandra. The data collector engine is open source. So if you're not using it directly from the data platform, which we'll be using, there is source code out there. The transformer engine, as mentioned, that's where we showed how to use it in the data engineering aspect. So that's where it brings in Spark into the data engineering aspect of StreamSets, right? So with the transformer engine, you can natively execute Spark, Snowflake, EMR. So any big ETL or data analytics tools can be used with the transformer engine. And then they have tons of pre-built connectors and native integrations, whether that be from applications, big data, SQL, NoSQL databases. So for us, Cassandra, NoSQL database, storage, warehouses, data lakes, etc., and also streaming tools like Kafka. Believe they have Rabbit as well. And so there's a ton of sources and a ton of destinations. So you can essentially build out any of the most common frameworks that people use in their platforms, right? And they have good material for their academy and tutorials. So if you're interested in using StreamSets, you can check it out. The links are here, and you can get the slide deck for this will be published right after this video, and it'll be put back into the YouTube description. So you can get it there almost immediately. So with a focus on the Cassandra connector, I have a link to the docs here, but essentially immediately it supports 1.2, 2.x, and 3.x. I didn't see any support for 4.x, so that might be something that plays into how you use StreamSets with Cassandra. So maybe you could potentially utilize the transformer engine or potentially use Spark to then talk to Cassandra, et cetera, or Kafka or whatever. Do parts of your pipeline and then have it feed into Cassandra elsewhere, right? And you can have additional authentication. So if you have a DSE cluster, You can do DSC authentication, Kerberos on either open source or DSC, SSL and TLS. And then the way that the Cassandra connector works is it works as a essentially in a sync to where it ends, right? So it works in batch writes. So there's two methods you could use. You could use a logged method of writes, batch writes, or a unlogged method. So the logged method is essentially atomic, so it's all or nothing. So if you have some failure, it'll fail, and the whole data set that you're transferring will end up in the error section or wherever you define your error handling on error. Do this with the records. So if some of the records fail, all of them will fail, and then the whole batch that you sent in that method would fail out. Versus unlogged, depending on your use case, might be more useful, right? So unlogged can do partial batches to Cassandra, right? So in the case of using unlogged batch writes, it would do partial batches, and if only certain parts of your batches failed, only those records would fail out. So if you have, depending on your sorry, I'm blanking on the word, but your fidelity of your data, right? You may prefer logged in your pipeline over unlogged, but if you're not really necessarily worried about high fidelity, you're more worried about high availability, unlogged may potentially be the better option for you in your use case. So for the demo, what we're going to focus on is spinning up data collector deployment from the control hub, and we'll show you how to do that. And while that's spinning up, we'll also take a look at some of the features in the control hub UI. And then if you want a more in-depth look at the UI, you can also check out our previous talk for Data Engineers Lunch on StreamSets for data engineering. So what we'll be doing is we'll be getting CSV data from GitHub. I have a CSV file that I used previously in a different talk. And that was using Spark and doing some ETL, right? But we'll be able to do that ETL using the data collector deployment. So as we discussed last time, someone brought up that you can do data transformations without having to have the transform engine deployed, right? So you don't have to have Spark to do transformations using the data collector engine. And we'll show you how to do that in a simple demo today. And then we have about 100,000 records in that CSV file. So we'll be using 100,000 rows from a CSV file and putting that directly into Cassandra. And then, as mentioned, we'll make some data transformations as well as do some arithmetic. There's also other ways you could do other transformations using a programming language. For example, you could use JavaScript, Python. I think Groovy is also an option. We could take a look at it. I forget the exact ones, but I know for sure that there's Python and JavaScript. You can actually write out functions that will take the input of data and then do some minor transformations on it and have output. And then we'll also spin up Apache Cassandra on Docker, and then we'll show you how to connect that in Control Hub, as well as then put together the whole pipeline, and from 100,000 records of CSV, do some data transformations, and then write it into Cassandra. All right, with that, I will go ahead and go to the Control Hub. So in the Control Hub, there's a couple ways we can do this. We can do a quick start, which is a way to quickly get up your, if you don't have any necessarily like specific configurations you want to do, you just want to go ahead and just quickly get up a data collector engine or a transform engine, you can go ahead and use a quick start. But there are good tutorials on here, as mentioned previously in the talk. But again, we'll just use quick start. We'll deploy a data collector using Docker. So you see how it auto-fills some of the things, but we do want to go back to configure deployment. And in configure engine, we want to go to the stage libraries because we need to add the library for Cassandra. So if we look for Cassandra, it's available, but it's not already selected. And if you're doing this after the fact, you can still add your engines. Or your libraries. You just would need to restart the engine once they're added. So that's just something to keep in mind if you're adding new functionality and you need to go back. You can always add more libraries as you need them, but it will cause a restart or will require a restart of your engine. So here we're using the Cassandra driver 3.x. We have versions. It's used for the Cassandra destination, which is writing to Cassandra. From what I saw, there wasn't a way to read from Cassandra, but again, that can be done with something like Kafka or Spark, depending on your pipeline and your use case. But we'll go ahead and select this. We'll hit OK, and we'll go ahead and move down to the install. So we'll go ahead and generate the install script, copy it, and then paste it into our terminal here. And so while that's going to bring up the StreamSets data collector engine, we can actually take a quick look. So what we're going to be doing is going into this build, and we're going to be creating a pipeline. And then once the pipeline's running, if we want, we can also turn that pipeline into a job. And so with the build, while that's running, and you can also look at your deployments as well as environments, engines, etc. So when we're setting up our Cassandra connection, we'll be doing it here in the connection section, and we'll take a look at that once we get to that part of the demo. So in our deployments, we can see the state and any tags we have on our deployment. So we see that our data collector is ready to go. So we'll go ahead and go to pipelines. We'll go ahead and create a pipeline. And we're just going to name it test. We're going to use the data collector engine. And we'll go ahead and move down. Oh, authoring engine. Okay, looks like it's still coming up. Let's go back here, set up deployments, click on this. Okay. So it looks like it's still starting the engine. All right, so while that's happening, something that I do want to talk about is the DataStax protocol that when you're setting up the connection, we'll get to this point once we set up the Cassandra connection, but essentially something to keep in mind is when you're setting up the connection, you have to select which protocol version that you're using. So you can reference this compatibility matrix. It's available in the documentation for the Cassandra connector, but essentially it gives you up to, I think, protocol 5 or 6. But because we're using 3.11, I believe, we'll just be using protocol v4. So that's just something to keep in mind there. So let's take a look here real quick. Okay. Let's just make sure this is up and running. Let's build a pipeline. Test. Next. Okay, authoring engine. So our engine is up and running, and it auto checked it for us. But again, you can switch out your pipelines to different engines as needed. So that's really cool functionality that StreamSets provides directly in their UI. So as mentioned, while this loads, is we are going to start with an origin, right? So there are a couple ways you can do this. You're playing around with it. You can use the data generator to generate your data. But what we'll be focusing on is grabbing, as mentioned, data from a GitHub. So right here, what we're going to do is configure this. So in the HTTP, we are going to change the GET request URL to this URL for this data I have here. We can pick the mode. We can do streaming, polling, batch, whichever one fits your floats your boat. If you have pagination, you can set settings on that. TLS data format for us, because our data format is in CSV, we're just going to maintain that for now. So we're going to go ahead and change this to a delimited option header line. It has a header line, and we're not skipping any lines. So when we do this, I wonder if it will let me preview with just the single section. It might not, but we can check. Okay, so great. So in our data, it just shows you input data, right? So input, because this is the origin processor, that nothing happens, right? But output, it takes the header line that we have in the CSV, and it recognizes that, And then it builds fields in the output based on the position of each record in the CSV file, right? So field 1, field 2, field 3, field 4, it'll map properly based on the header line. So we have a job title, employee ID, employee name, first day and last day. So just to clue you in, what we're going to do here in the transform aspect of this is we're going to take this first day and last day data. We're going to clean it, first of all, because right now we see that it's a string format. And we see that once we get to it, we'll show you the table definition we have in Cassandra. Essentially, we're using timestamp, right? So this won't actually transfer in properly. So we need to convert this into a format that will transfer in properly. And then we're also going to calculate, it's not super accurate, I've noticed, but we're able to get a close enough answer to the time that someone worked. Granted, because this is randomly generated data, sometimes the first day is actually later than the last day. And then sometimes that messes with some of the data, but we'll show you that we're just doing calculations, get the absolute value. So that way it's just a positive number. So it may affect some of the numbers. So that's just something to keep in mind, but it doesn't affect what we're trying to show you here in terms of taking data, transforming it, and then writing it to Cassandra. So what we're going to do next that we have this is we are going to send this to or close the preview, and we're now going to connect it to a expression evaluator. So coming back to where I mentioned where we could potentially use languages. So there's a JavaScript evaluator. There is a, it's in here somewhere, I believe. It's in here somewhere, but essentially we could like actually write code to do transformation. It's not super, from what I saw, super powerful in the data collector aspect of it, but there might be some cool things you can do with it. So in the expression evaluator, what we're going to do here is we're going to make some transformations, right? So in this first output field, which we have from here, right, we have our first day, right, which is the direct first day, but we're going to create a new field based on the transformation of that first one. So we're going to call this first day date. So what we're going to do here, I have this copy and pasted, but we're going to talk through what's happening. So in this command, what we're doing here, starting from the top down, we're going to extract date time from string, because if you remember in the preview, our string or our date is currently in a string, right? But we also need to do some transformations to clean up the data we have on the string itself, right? Because it's not formatted correctly, right? So what we're going to do is we're saying, hey, we don't really care about the time zone. We don't really care about the hours, minutes, and seconds. So we're just going to drop that, right? So we're going to use the substring method to take the first day column from the CSV, and we're only going to return the first 10 digits, which are year, 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 or the format is year, 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 month, month, day, day, right? So that's only what we're returning. And then within there, we're also going to substitute with the replace. We're going to replace the dashes with hyphens. So that way, when we're using the time extract date string, it recognizes the format. Because when I was playing with this, it didn't like the hyphens between the dates. So I needed to do a string replace using slashes instead. So that way, when it does the extract date time from string, it will be able to recognize and then convert the value we have as year, 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 dash, month, month, dash, day, day into year, 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 slash, month, month, slash, day, day. And then this will also turn it into a date time format. And so that's important, right? Because the destination, the table that we have in Cassandra, which we haven't created yet, but we know ahead of time that format's going to be date time. And so we're going to also do that same exact thing for last day, right? Let me just copy this in. And it's the same exact field expression. except the record value is just going to be last day instead of first day. Okay. And so if we preview this real quick, we can see what happens. So we see from here, as mentioned, we have string for first day and last day, right? And then if we go to the field expression evaluator, what we're doing here is we're creating two new output fields, and they've converted this string into a date time. And one thing to note is that when it converts the extract date from string, it pulls out some minutes, hours, seconds, but we don't necessarily need those, so we can cut them out as needed. So if we come back here, now what we're going to do is do a small calculation by converting the datetime, newly datetime generated into epoch. And there was no epoch in seconds, which was interesting. They only did epoch in milliseconds. That's the only time function option for converting into epoch. And so we just have to adjust the number of seconds we have in a day, right? So the number of seconds we have in a day in seconds versus milliseconds, it's a factor of 3 zeros, right? So if we go into here, we're now going to add another, and this is going to be days worked, right? And so in this output value, what we're going to do is copy in here. While we have this, let me open up the chat. I realized I had that closed. So just to talk about what's happening here. So again, looking from top level, we're going to round the value at the end. And again, as mentioned, we're taking the absolute value, right? So we are going to take the date time that we generated from the last day date, convert that into epoch in milliseconds, subtract that from epoch of first day. And again, as mentioned, some of the first day and last day's numbers are plus minus, right? So that's why we're just taking the absolute value, but it may affect the actual numbers that we're working with. But in the real world, this really wouldn't happen because this is just randomly generated data that I'm working with here. And then we're going to divide it by 86,400,000 because that's the number of milliseconds in a day. And so that's going to actually return us a long value. So what I found is that the math round and the math absolute values, or the functions, they return either, I think, int long double formats. So it doesn't actually let me pick what I want, or maybe I just didn't find the setting to do that. So that actually ended up being a problem that I found. So something to keep in mind when you're building with StreamSets is keep an eye out on the auto-generated field types, because when you're trying to write to Cassandra from here, right? So this will, let's go ahead and run the preview so you can see what I'm talking about. So here in this expression, we have 1,400. So that's about a little less than 5 years. This is about 5 years, right? Or 365 times 5 is, yeah, well, the number doesn't work exactly right, but it's showing you it's possible, right? So you can see here that it auto-generated the long data type. And so depending on your data type in Cassandra, it won't match and it'll fail out, right? So what you need to do is either do a format type change, which we'll do here, and we'll show you how to do that, or well, you'll need to do that actually regardless, but this long type would map to a big int, but because our schema currently in Cassandra uses int for days worked, it fails out, and so it doesn't actually write properly to Cassandra, depending if you're using logged or unlogged batch writes, right? Logged is atomic, so if one fails, all fail. Unlogged is depending on the batch, but because if we're doing long to int in Cassandra, it'll fail, and then all of them will fail regardless of if it's logged or unlogged batch. So what we're going to do here next is we are going to fix that long format, right? We need to convert that into INT. So what we're going to do here is we're going to do a field type converter. And what we're going to do here is make a conversion from by field name or by data type, right? So you can pick what you want to do, but for us, we're going to do by field name because we only want to change one field type. Say if we had multiple integers and we wanted, or multiple long fields, and we wanted to multi-change them, it would be more applicable to do it by data type. Because we're only focusing on one and we don't want to change other options as well, we're just going to do by field name to make it very specific. And we're going to do days worked. Again, that's the generated auto long format. And we're going to convert it into type integer, which will then match the data type we have in Cassandra. And you can always set, based on your each configuration, you can have error handling. So you can either remove the field, set as null, don't convert it if it's an error, or send it to error. So by default, we'll just send it to error. We're not worried about any major data error handling right now. So yeah, let's go ahead and preview this and we'll see what happens, right? All right, so we have our data here coming back as strings. And then what we're going to do is convert those strings into date times as new fields, and then also generate the days worked by doing essentially a date diff between the two dates. And then we do a field type conversion to change this days worked to long, because our Cassandra schema uses INT, not big INT. We are going to convert long into integer. So then that would feed into Cassandra without any issues. So now we are at a spot to connect to Cassandra. So we are going to first spin up a Cassandra container. So let me go ahead and copy and paste this command in here. All right, and while that happens, it shouldn't take very long. We are going to go into our setup in the UI. We're going to go to connections. And let me go ahead and delete this because that was an old one from testing. So this is a brand new container. Obviously, the connections wouldn't change because I'm not doing super configuration changes. But the only thing about this Docker command to keep in mind is that my port is exposed at 9042. And so what we're going to do here is we're going to create a connection. So we're going to call this Cassandra, or I'll name it Docker Cassandra, right? So that's our specific connection. So we can auto link it to whichever pipeline we're using or whatever engine we're using. And then the type, we're going to select Cassandra. And we're going to go to, wrong one. Type Cassandra, save and next. And then here is where we need to set our essential contact points. So our host names, ports, etc., authentication provider, and protocol version. So remember, protocol version, we talked about it here based on this compatibility matrix. Because we're using 3.x or 3.11 or 3.x in general, we can use v4. So we'll go ahead and set that first. So we'll use v4 in here. And because I'm on Mac right now, my host name might be a little bit different from if you're using Linux or Windows. So for me, my contact point is host Docker internal. I tried using, so if you're using Mac and you're trying to replicate this demo, I noticed that 127.0.0.1 didn't work properly when you were testing the connection. And then also using just maybe the IP port of the Docker didn't work properly. And then also using my local IP address didn't work properly. So then I went to this host Docker internal, which I had used previously for, I think, my Metabase and Cassandra demo that we did previously. And I ran into similar issues then. And I remembered that I had used host Docker internal. And so I'm reusing that same thing and it works properly for Mac. So depending on what OS you're using, your contact points might differ a little bit from mine. And as mentioned previously in the slide deck, we can set authentication, right? So if you're using DataStax and you're using username and passwords for DataStax, you can set that for your authentication provider. If you're using Kerberos, you can set that as well. And then if you're also using TLS or SSL, you can select it and then put in all the different options that are needed. If you have remote or local, depending on what you're using, you can fill it in here. But because we're not using TLS, we can ignore it. We're not using any authentication right now, so we're just going to select none. So what we're going to do here is we're going to test the connection. And then if there's an error, it'll tell us. So for example, if I change this to 127.0.0.1, we'll get the error saying it can't connect properly, right? So failed to establish connection to Cassandra, no host available exception, essentially, right? So depending on what IP address you use here, it might fail out. So if you're using Mac and Docker, your option might be host Docker internal. But again, if you have a deployed Cassandra instance on maybe like something free, like a free trial like Avon or Instacluster, or if you're using a variant, your contact points might differ. And then if you're in the cloud, you might have different settings for TLS or SSL to talk to your connection. So now that we have that, we'll go ahead and hit save. And then we will go back to our pipeline here. And we will now start setting up the Cassandra instance of it, right? So before we do that, we actually need to set up our Cassandra. So if we go back to our terminal here, we're going to docker exec it Cassandra is my Cassandra Docker name. And then we're going to open up CQLSH. So let me increase the zoom real quick so you can see. So what we're going to do here is we're going to create a key space called demo, simple RF of 1. And we're going to create a table, right? So again, we're assuming that this table is already created in the real world, and we're just going to create a pipeline to feed data into it. But because for this demo, we're creating the table. So what's going to happen here is we have previous employees' days worked, right? So we have employee ID, which is UUID, job title, text, employee name, text, first day, timestamp. Remember, we converted the string that got picked up when we pulled it in from GitHub. We changed it using the expression evaluator, and we now have a date time format that will fit into the timestamp that we're creating in Cassandra. And last day, timestamp, and again, days worked, INT. If we kept the long format that was in StreamSets, we would need a big INT format, date format for days worked. And primary key, we're just going to use employee ID. And then we'll just do a describe demo.previous. And we see that our table is created. So what we're going to do here is I'm just going to go ahead and do select account from demo. And then just to see, once we run the pipeline, we can see that data is coming in. And for here, we are now going to put in our destination, and our destination is going to be Cassandra. So when we're configuring our Cassandra connection, because we've already added it in the setup section under connections, we can use that directly here. So in the connection, you could either use a pre-populated one, or you can do it based on the specific connector in the specific pipeline. But in terms of controlling it, it would make more sense to do it ahead of time. So we're going to go ahead and use Docker Cassandra. It's going to ask us for the table name. So we're going to use dot notation here, and we're going to do key space dot table name. So demo dot previous employees days worked. And then we're now going to map our fields to our column names. So our first field we're going to map is employee ID, and that's going to go to employee ID, right? So we're going to add another. It's going to be job title, right? We didn't make any changes to job title. Add another. Next one will be employee name. Employee name. And so here is now where we pull in our newly created outputs from the expression evaluator and then the field type converter, right? So the first field here is going to be first day. And then if we use first day here only, it will fail, right? Because this field right now is currently still the string format, right? But because we generated a new copy or a new output, we're going to use first day date. And then here we're going to use last day date. And then we're also going to have our days worked field, right? First day, last day, and then days worked. And so again, this is that absolute value rounded number that we generated from epoch minus epoch of first day date and first day or last day date. And so from here, we can go to show advanced options. I'm going to leave it as is to show you some errors that I ran into. Okay, so based on default settings, it's enabled batches, batch type logged. Remember, batch type logged means atomic, and then we can switch it to unlogged if we want. Max batch size, 65,000, connection timeout, write timeout, consistency level, and then log slow queries. And so here we are going to go ahead and do a test run. And so what's going to happen here is we are actually going to start seeing data come in and the output. So we talked about this previously. Before, but you see how it says batch too large, right? So this was something I ran into to fix. So after playing with a couple different configurations, I just reduced batch size to about 100. So depending on your workload, that's something to keep in mind. Depending on if you're using logged or unlogged. If I'm using unlogged, I think my max batch size could be increased potentially, but we'll just leave it as the default logged, and then decrease the max batch size to 100. And we'll go ahead and now bring this back into a test run. And we should now see successes as we go in. And as we start seeing successes here, we'll then go look at the count in Cassandra. So we see 1,000, 3,000, input, output, green. If there were errors, the numbers would stack up here. But before we do that, let me come back to the terminal. Let's do that select count. 20,000, 26,000, 32,000. So we see that data is going in from our CSV, getting transformed. It's writing to the proper column. We'll show you that it's writing to the proper columns, but it's being able to be transferred in without any significant issues. And then as we can see here, we can see real-time inputs and charts to help you monitor your data platform, as well as your pipeline individually or your job. But you see here, it's finished. So it'll wrap up, but we can see here the processing time that happens per each stage processor. So most of the time happens in writing to Cassandra, smaller amounts of time for the actual GET request and doing conversions. So we see that for our specific workload, most of the time was for writing to Cassandra. But again, this only took less than a minute to write 100,000 records into Cassandra. So here we can also see record counts. So if there's any if there's any branches, we could be able to see it broken down. We can see record throughput, stage processing timer as well. And then if we wanted to turn this into a job, we would need to check it in here. So essentially it's a way to version control your pipelines, which is super cool. And then you can adjust who has access to what versions of the pipelines. And then we can save and create a new job, which we won't be doing, but you can check out how we did that previously in our data engineers lunch for StreamSets. And with that, yeah. Oh, before I forget, let's do a select all from demo.previous or demo. Oh, that's because the select is incorrect. Select all from previous or demo dot previous. Oh. Okay, so let me zoom out a bit here, so that way it's all on one line. Command minus. Okay, so here, if we scroll up, we see employee ID, we see days worked, employee name, first day. So it pulled in the date time, job title, and last day. So let's take a look here. So 376 is about a year. Again, the numbers won't be accurate right now just because of the data we're working with. But we see that, okay, 2011, January 18th, and we see here January 2012, 2019, so that's a little over a year. So that number matches up relatively well. So if you look at this one, 370, it's another about a year. So this one is 2008, January 26th. This is 2009, January 30th. So the numbers aren't super high fidelity right now, but we are able to take 100,000 rows from a CSV, make transformations to clean up, so data wrangle our string format into datetime format, and as well as calculate days worked using the first day and last day all from the CSV in 4 steps. And obviously we took longer because we were explaining the process, but to put together this demo and to do it yourself, if you know what you're doing with StreamSets, this is like a 15-30 minute task at max. But yeah, with that, we will go ahead and wrap up the demo portion. If anyone has any questions, feel free to drop them or speak up. If you're watching live on YouTube, you can drop them in the real-time chat, and I can take a peek over as well here. But yeah, if anyone has any questions, feel free to speak up. Okay, it doesn't look like there's any questions in the YouTube chat. It doesn't look like there's any questions in the Zoom. So with that, we'll go ahead and wrap up today's Cassandra Lunch. Thank you everyone for joining us. If you're watching live on YouTube, don't forget to like, subscribe, and turn on your notification bell. So that way you can get notified every time we do go live. But again, because we live stream directly to YouTube, if you missed the live event, you can always rewatch it on either of the playlists, Cassandra Lunch playlist or Data Engineers Lunch playlist, or just find it on our YouTube channel, youtube.com/AnantCorp.